Hello fellow Unreal Engine artists, designers and developers. Can you see the cube in this landscape? No? Well, that's because it is perfectly blended with the underlying textures, and that's what we'll be covering in today's episode, Better RVT Blending. Welcome back to the latest episode in this landscape materials series, and in today, which is a part 2 of Runtime Virtual Textures, we'll be covering distance blending to finish off our RVT setup, and then updating our RVT blending to make it much more sophisticated. So before we get going on the core of today's tutorial, we need to do some housekeeping and talk about virtual texture memory. So if I open up our runtime virtual texture assets let's do it for the color one here, and you can see it on the right hand side here. There are two parameters here that control the memory usage. So you've got the size of the virtual texture in tiles and the size of each virtual texture, and if you multiply those together you get the total memory size that would be required if you wanted to stream everything in full detail. You won't ever need to do that all in one go, but you can increase these values and decrease these values if you want to increase the resolution at the cost of more memory on the GPU. So at the moment I've got this set to 10 and 2, so that's 1024 times 256. And if we go into, in fact let's just close that down, go back to our material instance. If I switch on my RVT to show it in place of the standard shader, after a second it will pop back in with the shader. But what you'll notice is that as I move around, some of the textures are blurry, particularly these ones in the background. So that is a symptom of an issue with the virtual texture memory. And what happens in the background is that you have these virtual texture pools that are assigned, and if they're too small then it can't stream out the required resolution, and if you have larger resolutions the problem gets even worse. So let's first of all I'll show you how you can identify the problem. So if you go to the console and if you type residency, there's this virtual texture command, console command, RVT residency show, and if you put a 1 after it, switch it on, you see these graphs, and these graphs are showing the runtime virtual texture memory for each format type. So DXT5 is our main color textures, G16 is grayscale, and you can see that the bulk of these are the standard sort of color textures. I believe normal textures are in there as well. So as I move around you can see that that red line here, which is the memory requirement, is almost hitting the ceiling. In fact, it is hitting the ceiling, and that's why we're getting that blurring, because it doesn't have enough memory in what's called the virtual texture pool to stream out that resolution. So we can fix that if we go into the project settings. So go into Edit, Project Settings, and scroll down on the side until you find the virtual texture pool menu, and there are some settings here. Now this second one, this pool auto grow in editor, you might have this ticked on, and if you do, it tries to size the pool dynamically in the editor, and you're probably seeing a message cropping up in the bottom left of the screen all the time saying auto grow texture, auto grow texture. It gets quite annoying. So what we can do while we're in the editor is we can switch that off and we can increase our default size. So let's up this from 64 megabytes to 512. There are other things in here like fixed pools and transient pools. I'll be honest, I'm not an expert in these, so I don't know how those would be used, but this will update the general texture pool for us. So let's now come out of here, and you notice that our red line now is way below the ceiling, and also visually I can see that those textures in the background are no longer blurred. They are pretty clear in the background. And I want to show you something else as well. It's more out of interest. If I get up close to some textures here, you can see that it rose slightly, and obviously now I'm not having to stream so many tiles, so the texture pool isn't being too demanding. As I come out, you see it's going up a little bit. But what's interesting is if I come right out, you would think that the texture pool would grow, but it's actually coming down. And that's because even though there are more tiles to display here, because they're far away, it's not having to stream them at a top resolution. So it's an interesting phenomena that you would think that the large overview would require more texture, but actually requires less. However, if I get close to the ground again, you can see that it is going up a bit, only a little bit, and then as I get closer to other surfaces, it goes up again. But you can see at the resolution I'm at, so I'm only at 1080 here, so I don't really require this size. I could go down to 256 probably. But if you're at high resolutions, or if your virtual textures are at a high resolution, you'll need to change those pool sizes. So let's switch off those graphs. Go back into the console, and I can use that command again with 0, and that will switch off the graphs there. One final thing as well to talk about before we get into the main tutorial is I was wrong about the triplanar. So you can see if I go to some of the cliffs here, if I go into the material instance and I switch triplanar off, those are our original textures with a bit of the stretching, particularly up on this sort of corner. If I switch triplanar on, that is working fine, even with the runtime virtual texture. So I said that the runtime virtual textures didn't work with triplanar. They do. So the only thing that our runtime virtual texture is missing is the blending. So you can see that in the foreground, I'm getting the tiling for the far tiling, and I wanted to do the near tiling for where we're close to the camera and far tiling for when we're away from the camera. So let's talk about how we do that in our RVTs. So I've got our master landscape material open, and in that we've implemented this depth fade mask to blend between the near tiling and the far tiling. But the problem is that the RVTs don't have the concept of camera. So we can't use this logic to generate our depth fade mask. But there is an alternative for this, and I'll explain how it works. If we go back to the landscape, I've put on this view here where I can explain this. As you are rendering out the textures on the landscape, they are being rendered in different levels of resolution. So this is a concept known as bitmaps or MIPs. So textures close to the camera where it needs the full texture resolution are rendered in the full detail. So if we have a 2K texture, this red portion here would be rendered using the 2K texture. And then as we get further back, we can halve that to a 1K texture, then a 512 megabyte, and then 256 megabyte. It's one of the reasons why textures are powers of 2, because it's easy to divide by 2 as you go into the distance. So these are known as MIP levels. So the one closest to us is MIP level 0, and then MIP level 1, 2, 3, 4, 5 as you go into the distance. Now we can actually get this MIP level in our material. So we can use that MIP level as a way of knowing whether the texture is closer to us or further away, and we can generate our depth mask using the MIP level instead of the camera. So let's implement that into our material and see how that works. So if we go back to the landscape material, what I'm going to do is I'm going to create a new material function for this depth fade mask, because it's going to become a little bit more complicated. So let's open up our content browser, go into material functions, and we'll do a new material function. And I'll call this MF depth fade mask, and open that up. There's no input for this, there is just an output, which is the depth fade mask. And then go back to your master material and let's drag these 4 nodes, do a Control C, and then paste them in here. And that would be our mask as it is at the moment. So now we need an alternative if we're writing to the runtime virtual texture. So let's go underneath here and start to work on that. So as I said, we can get the MIP level of the texture that's being rendered. And the way we do that is use a view property node here. And this provides a variety of properties that we can access within our material. So you can see in the drop down here, we have different levels here, and one of them here is virtual texture output level. So that is the virtual texture MIP level that we're using. Now what I want to do is I want to, remember I said it was 0 when it's closest to us, 1, 2, 3, 4, 5. I want to get it into the sort of range where we can use these parameters for blend distance start and blend distance transition. So to do that, what I'm going to do is I'm going to put in a value of 2. So I'm hitting 1 on the keyboard to get a value, and I'm going to put value of 2, and then I'm going to do a power node and raise 2 to the power of the MIP level. So that means that for MIP level 0 we'll have 2, for MIP level 1 we'll have 4, 8, 16, etc. And now I'm going to multiply that by 1000, and that gets us broadly in the same range as the distances that the camera depth fade we're using. So for the close ones we're sort of 0 to 2000, for the MIP level 1 we're 2000 to 4000, etc. And now what we can do is we can start to create a mask based on the start and transition values. So if we take the blend distance start and do a subtract, so we're going to take the value that we've created, this artificial distance, and then we'll subtract the start distance. And let's just move this back so it's a bit easy to see. And the next thing we want to do is have the transition here. So again, like we've done with all our masks in the last few episodes, we do a divide to do the blending, and we're going to divide by the blend distance transition. And let's just clean up these nodes a bit here so that we can see what's going on. And last thing we want to do in this chain is to do a saturate to clamp the mask between 0 and 1. So all stuff we've done in the past. Okay, now you would think we need to plug this into our depth fade mask, but how do we know when we want to use our camera depth fade or our virtual texture depth fade? So there is a switch here, and it's called the runtime virtual texture replace switch. So if you look for this, runtime virtual texture replace, what it means is that when it's running through this shader as a standard shader, it will use the default path, but when we're writing to the RVT, it will use the virtual texture output path. So all we need to do is plug our regular depth fade into the default path and our RVT depth fade into the virtual texture, and then we can plug that into the output. So it will choose the right mask for the right output. And let's just do some commenting around here. So around here we'll do standard camera depth fade, and then around here we'll say RVT MIP based depth fade. Now the last thing we need to do is we need to implement this depth fade mask in our master material. So let's go back to the master. Let's delete the nodes that we copied and pasted, and then drag this depth fade mask into here and plug it into the depth fade mask reroute. So now our depth fade mask has two options. One when we don't have RVT and one when we do have RVT. So let's save that and go back to, let's switch RVT off in our master material for now. Let's go back here. So this is the standard shader, and you can see that we have definite near tiling going on here. And actually, let me zoom out. Yep, and we can see the far tiling over there. So, but nothing new there. That's without RVT, so we'd expect that to work. Let's get a bit closer again. Okay, now, moment of truth. Let's switch on Show RVT. And now we can see that we have the near tiling here. So that's working. And if we zoom out, yeah, we have the far tiling. So we've done a MIP-based distance blend that works fine. Now, it probably won't be exactly the same as these values where we've got the blend distance start and transition, but it's probably close enough that it will work fine. So that's now our RVT working pretty well. So we've now got blending going, better texture resolution by getting the pool size set up so that the distant textures look good, and we've also got better blending, distance blending now. And that's important for when we're doing our mesh blending, which we're going to do in a second, because without this near tiling working, those mesh blends are going to use the far tile size and they're just not going to look very good. So let's move on now and do part two, which is we're going to improve our RVT blending function for doing the mesh blending. We'll add a couple of extra features into that to make that more sophisticated. So hopefully you've still got your cube in the project, and I've reset it so that it's facing directly up again. So we created a basic RVT blending function here, but it only had a single parameter, and to be frank, it didn't really do a lot. We had to really crank up the values to even get it to show here. So it went from 0 to 50,000 and it's barely showing here. So we haven't really done enough in this RVT blend function. So let me just set it to 0 again for the moment, and let's look at where we got to. So in your material functions, we've got this MF RVT blend where we're blending our color and our normals based on this height mask. So at the moment, we were getting the height of the pixel on the object, and then we were dividing it by a blend distance to get the mask. But what we want to do is we want to do our usual subtract and divide to get subtract to get the end point of the mask and divide to get the blend. So let's improve this a bit. So we will move this over and we'll do a subtract from the height that we have calculated, and we will subtract, if I duplicate this, a parameter, and we're going to call this blend start. We'll set the default value to 0 and plug that in here. And then after we've got our edge point of our mask, we will then do our divide. And let's call this, we'll just reuse this parameter and we'll call it blend transition. And we'll set the default again to 0. And this should give us our standard mask with the edge point and the transition softness. And then we'll plug it in. So let's test that out. So let's do a save here. Come back to our cube. And now we have two parameters here. So if I put something like 100 in the blend start, you can see that's working much better now. So it's coming up to a particular point, and if I do blend transition of 100, you can see that from that point it's then transitioning. And I'm seeing that we're still getting this sort of light value, so maybe I haven't changed the specular value on this cube. I showed in the Q&A video that there was a mistake I made on this cube material, so let's just quickly check the master material for this. So the M cube. Yeah, so the specular value is 1 at the moment. You need to change that specular value to 0. That was a mistake I made. And now you can see that I've got the darkness back in that blend. You can see this is not a great blend anyway because the sides are perpendicular and so they're just sampling the 1 pixel underneath. Anyway, we'll do something about that in a minute, but let's just quickly look. If I rotate this cube and let's just then move it down into the ground a bit more, come out a bit, you can see that's blending pretty well. Not quite as well on that side, but it's a bit darker. But again, I'll show you why that is, and we'll fix it in a minute. Let's just concentrate on the blending for now. But that looks good. And now if I can change the blend start, make it lower, make the blend transition higher, and you can see that that is looking pretty good. Not perfect, but pretty good. So what else can we do? Well, this problem with the, if I reset the rotation here, this problem with the edge sides showing up these streak lines can be sorted a little bit if we consider the normal directions of the surface and only apply it when the normals are facing maybe up or more up than to the side. So we can add to our mask to do some normal blending as well. So let's go back to the mask, and what I'll do is I will move this height mask over a little bit to give us a bit of space, and we'll start to create a mask based on the normal values of the object. So if I right click and do vertex normal, so that tells us the position, the direction in which the object faces are pointing. And if you do a mask, component mask here, and what we want to do is we want to select just the B component, which is the up component. So what this means is if the face is facing directly up, then this will be a value of 1. If the face is facing exactly to the side, this will be a value of 0. So we can use this to mask our blend here, so that it only blends where maybe it's facing up. So let's look at our mask at the moment. So the mask is, if it's 0, it uses the runtime virtual texture sample, and if it's 1, it uses the regular color. So we want it to show when it's 1 here, but it's 0 here. So in order to do that, what we can do is we can take the output from here and we'll reverse it. So we're going to make 0 and 1 the other way round, and then we can then multiply by this value. So that will preserve the mask where the normal is 1, and then we need to then reverse it again to get it back the way round we need it for our blend. And now we can plug this output into the alphas. And we'll call this overlay normal blend mask. So we'll refine it a little bit in a second. At the moment, all it does is show the mask when the vertex is pointing upwards. So let's save that, come back here, and what you can see, if I move a bit closer, what you can see is we can see a little bit of the masking going on up here, but nothing at the side. So let's just put the blend start up to 200, and now you can see that it is only showing the blend on the upward facing normal and nothing on the side there. So It's pretty good, but we don't want it to be so digital. We'd like to have a blend of normals between facing up and facing on the side so that we can see some of the oblique angles as well. So let's go back and do a bit more refinement. So what we'll do is let's have a control here. So let's create a new parameter. Let me steal the blend transition, duplicate that. And what we'll do that with this is we'll call this one blend normal, and we'll have a default value of 0. So we want to be able to, when it's 0, we don't want to use this mask at all. And when it's 1, we want to use whatever the vertex normal is here. So let's actually do a saturate here to clamp it, so that even if I put a value of 2 in, it's only between value of 0 and 1. And then we'll use a lerp, so that, and plug that in there, so that if this blend normal is set to 0, we will set our value to 1, as if the mask is always on. If this is a value of 1, we'll use the vertex normal, and that way it'll blend in between those. And that's our new multiply here. And let's just check that these parameters are in the right order. So blend start, we'll do sort priority 1, blend transition, sort priority 2, and blend normal, sort priority 3. Okay, let's come back here, and you can see that it is fully blending the cube again, because our blend normal is 0. So we're not using the normals at all. If we set that to 1, we're blending just on the up face angles, and if it's in between, it'll be a little bit of those, but you're not seeing much because this is facing completely to the side. So I'm going to rotate it a bit here, and then we can play around with the blend normals. So 0 shows everything, and as you go up in values, you can see that it does a slight blend. So you can change this to have the blending of the normals not quite so digital. So let's put this back to, actually let's put it back to 0, so that we're blending everything. Now there's one final thing we've got to fix in our blending function. It's pretty subtle, but if you look at the faces of the cube, you might have noticed that the texture looks like it's stretched a bit, and that's because it's using the normal as if it was projected from the landscape underneath, and in reality we want the normal to be as if it's sitting on the actual surface. So we need to do a little bit of transforming of the space in which that normal sits. So actually there's two places we need to do that. Firstly, when we write the RVT, so if you go into your master landscape material and find the section where we're writing the RVT, so this is where we write the normal information out, and what I want to do is just transform this normal. So use transform, vector transform, and by default it should be set to tangent space to world space, and then plug it into the normal. What that means is that it will take it in the space on which it's sitting and then convert it into a world space normal, so it's in a common format in the runtime virtual texture. Okay, and with that done, we then need to translate it back into the tangent space we need for our object when we read it back out again. So click to save and apply that, then go back to your RVT blend function, and now on the output of the runtime virtual texture sample, do a transform again. This time though we are going from world space, which is what it's stored in, to tangent space, and that will therefore put it in the right space for the faces of the object we're putting it on. And then let's just move that over here. We'll then plug that on into the A input of the normal here. Let's click on save here and go back and after a brief moment where it recalculates a shader, you can see now it looks as though it's blended perfectly on both sides of this. So it's no longer stretching these normals here. Those normals are acting as though they are on that surface, just as they were on the surface below. So that's fixed that problem. However, there is a downside to this. It doesn't work, having these accurate normals doesn't work in every circumstance. Let's rotate this round again a bit just to see if it works. Yep, it works well on this at all different angles, but if we look at our grasses over here, you can see there's this horrible black band where the blending takes place. So it doesn't always work to do that blending. So we really need to have a switch to decide whether to switch that on or off for different meshes. So final thing we need to do in our RVT blend, come back here and we'll add a static switch parameter. I'm going to call it accurate normal projection. By default it'll be off. So if it's on, we'll take that transform and plug it on into input A here. Again, we just need to give it a bit more space. And if this is false, then we're going to take the normal without any transform and then plug that in. So that's exactly as we had it before. Okay, and click on save here. And you can see that the grasses are back to normal because the default for that blending was off. And if we go back to the cube with the accurate normal projections on, in fact that'll probably be off again, yeah, because we set it to a default. So select your cube, go, oh, we don't have it in the right group, so go back to the RVT blend function, choose that switch and make sure you put it in the RVT group, parameter 4, click on save, and now we've got this extra switch here. So you can see that with the cube it's looking bad again because we've switched off that accurate normal projection. If we switch it back on, yeah, it blends nicely with the surface underneath again. So let's finish off today by applying our new RVT blend to a Megascan's texture to see how it works. So good news is, as of a couple of days ago, they brought Quixel Bridge back. So instead of Fab, we can use Bridge. It has a better workflow for many people, so let's use that. So go to Add and find Quixel Bridge. Search for rotten tree stump. And you can see there's various ones here. I've picked this one here, which has got a slight sort of point to it. You can see I've already downloaded it. And we'll add that to our project. I'm doing it in medium quality, but you can use whatever quality you require. So I'll click on Add. And you can see that it's added it into the folder. Let's close down Quixel Bridge. We've now got it here with all of the textures and the material instance. One of the nice things about the Megascan's downloads from Bridge is that instead of using the materials in the engine, it creates its own project in the folder. And that means we can add our RVT blend without affecting any other projects. So the first thing we need to do is put this into the landscape. So I'm going to drag this rotten tree stump mesh and I'm literally just going to plonk it onto the landscape here. And you can see that as it stands at the moment, it doesn't really fit in. It's a little bit too light and it definitely isn't blending at the bottom here. So we need to update the material to add in our RVT blend. And I'm just going to update something on our material function for the RVT blend that will be useful going forward. If we let's shut this down temporarily. If you go into your RVT blend function and just click on the empty space, so you've got the general parameters, you've got this exposed to library function. So previously we've been dragging our material function into other material shaders. If we click on this, we'll be able to right click when compiling a material, when constructing a material, and find this. And we can give it a category as well. So we could give a category of RVT. Okay, so we're finished in here. Let's just save that and come out. Now let's go back to our content browser and find those Megascans, 3D assets, rotten tree stump. Let's open the material instance up. So it's open up on the right hand side here, and the parent material is this MS default material. So double click here to open it up, and now we need to add in our RVT blend. So let's move the final output out a bit. It's using material attributes here. So what we'll need to do is break the material attributes, then right click, and we can now search for RVT. There's our RVT blend in the RVT category, and we'll plug in the color and normal into there. We then need to make material attributes, and let's plug in the color after the RVT blend and the normal, and we also need the metallic roughness as well. So metallic roughness. Don't think this material uses anything else. I think that's everything here. And then we will plug the output into there. So now we have updated the Megascan's material to use that RVT blending here. So believe we've got everything. Let's put specular as well, just in case it does a specular. It might do a specular sort of specular value as well. All right, save that. Let's close that down. Come back to our tree stump here, and over in the right hand side we now have 4 new parameters here. So before we change our RVT blend, let's just, let me get this slightly closer. Let's just go through the parameters that are generally available for this. So the main one is this specular here. I want to reduce that to 0 so that it doesn't have any shininess on that. That'll help with the blending as well. I think that's the only thing I need to do. Right, okay, so let's start doing our blending. So let's first of all put in a blend start value. We'll put in 50 there, maybe don't need that much, 20. And you can see straight away it's got the right color compared to the underlying texture from the RVT. That's good. Let's do some feathering as well. So I'll move this over so you can see blend transition. So let's do 20 there. So it feathers it slightly going up. Now we can look at our blend normal. If we only want the upward facing normals from that plinth, we could do 1 here. And you can see now it's only doing all of the bottom upward facing faces there. Or we can do it somewhere in between, something like 0.5. That includes a few of those ones as it goes in. So we're almost there with the perfect blend. The only thing is I can still see the line where it joins because the normals are not being blended correctly from the underlying RVT texture. It's not using the planes of the tree stump. So we can now use this accurate normal projection. Click on that, and you can see that almost by magic, that bottom bit looks as though it is completely integrated. So hopefully you've seen from this example that these blend parameters and the new blend function we've put in place is much more accurate and useful than the one we did in the first RVT episode. So I think we'll leave it there for today. It's been another long one, so thanks for your attention and stay tuned. I'm not sure what I'm going to be doing in the next episode. I'll either do quick one on some tiling refinements, or we might talk about displacement. But both of those will be coming up soon anyway. So stay subscribed, and I'll see you in the next one. Bye for now.